Hello and welcome to lesson 1 of week 8. My name is Mildred. In this lesson, we are going to look at what an index is in SQL. We're going to work with the classic models database and we'll use the orders table for this demo. Now, when we want to search a record, we usually go through the whole record to search for a particular match. This is called sequential searching. This is very time consuming, especially when we have large record set. To solve this problem, we have indexes that we use to provide a quick lookup mechanism. An index is used to locate rows with specific column values. It is like a B-tree data structure that is created to improve the speed of the data retrieval. When we create a table with a primary key, MySQL automatically creates a clustered index and it calls this index primary. So every time our storage engine is InnoDB, we have one clustered index, and typically that auto increment integer column is used for the primary key. So this clustered index will enforce the order of the rows in the table. If we want to check what indexes we have on the table, we use the command show indexes from the table name. So we want to show this from the orders table. So we have the primary index that is created automatically and is created on the column order number, and we have another index for customer number. This index type is B-tree, like we said, so we can see the indexes that we have on the orders table. As good as this is to help us speed up our search and lookup, it has an impact on the write performance, because whenever we have an index and that record is updated, the index will need to be updated. If we want to see how MySQL internally performs queries, we can add explain to the query. For instance, let's say we want to select all from the orders table. So we can say explain select all. When we run this, we will have the select type simple table orders partition null type all. It has no keys, it just returned everything, 326 rows. If we want to add a where clause, let's say where the status column is equal to shipped, we now have this extra using where here. All right, so we see that this is done without an index, and when we have a very large table, this is going to limit the performance of this lookup. So what do we do to make this kind of query run faster, especially in a setting with big data? We want to add an index for any frequently looked up query. For instance, if we have a dashboard that shows all the orders that were shipped, all the ones that are cancelled, all the ones that are disputed, and things like that, we need to run that query all the time. We need to have an index for that type of query. Let's create an index for this query. In MySQL, we create an index. We use the create index statement like this. So we say create index, and then we give a name to the index. Let's say we want to create an index called, let's say, ship status. So I'll just name it IDX ship status, right? So create index name on the name of the table, which is orders, in a pair of parentheses the column you want to use. So on orders, and then I want to do this on the status column. Now when you create this, you can add an invisible, like this invisible statement here, and all this does is when you want to do a performance test first. So you are a database administrator and you have a lot of records on your table. You want to do a performance test and you want to make this index invisible to observe the effect on the query performance first before you remove the invisible option. Or you want to delete an index and you want to see how it impacts performance before you drop. You want to make it invisible first, and dropping and re-adding indexes on large tables can be resource intensive, and so we can add invisible like this, but for the purpose of this lesson we will not add invisible because we want to use it right away. All right, and so when we create this index, we run this, we can now use the show the indexes on the table statement to see the indexes that we have. So let's say show indexes from orders, and so when we run this, we can see we have the ship status index here. So let's explain select all from orders where status is equal to shipped. We now see that it uses this index to make this run faster, and it selects all of the orders where the status is shipped. So now we understand how to do this, but this is a string or a sequence of characters. The index we created is on a column that has characters and not numbers. This again can have issues, and when we normally create index on an integer column like the auto increment column, it's faster. When we do that on a column like this, we can have performance impact on this. So what do we do to make this better? We can create an index for a character string columns by checking to see what the unique values in those columns are. We can use a prefix to now look at how many prefix from that character can we specify in the index that will make every cell in that column unique. Let me do this. We know that we want to select all from the orders table where the status is shipped or where the status is cancelled. We want to know the number of unique status we have there. So the first kind of exploration you do is to select, let's do distinct status from orders. Let's select count. Let's count the number of unique status that the orders table has. So we have 6 unique status in the orders table. Now we want to see what if we use the first 2 letters for each of the status, will it still give us 6 unique counts? So let's run this. So we want to select count distinct. Now we want to see if we use the first 2 letters for the prefix. So we use left, and we want this for the status column, and we want to try to use 2 characters from the values in that column. We want to use the first 2 characters. So for shift SH, for cancel CA, and the likes. Is it going to conflict and result in non-unique values on that column? So we'll do this like this, and we can give this as an alias. Let's give it the alias unique rows from others. So when I run this, we still have 6, which means that 2 makes sense for us to use when we want to create an index. So we can create our index like this to optimize performance. Create index, we want to do index instead of shift status. Let me just put index status like this so we can change the name on orders, and then we want status, and then now we want just 2 prefix. Okay, so this is the way to optimize this further. And when we run this, we have the new index created. So we can check the indexes that we have on this orders table. So I'm going to comment this out, and we'll say show indexes from orders. And now we have the index status here. So we can see that this index is created as we want it to be. If we want to create a unique index, like an index that has no duplicate value, we can just add the unique keyword when we write our create index statement. And if we want to have this index on multiple columns, let's say for instance, let's try to create an index or a unique index, and we want this to be on a multiple column like a composite index. So let's say we want to create a search. We want to get the customer number and then the order number for the customer. So we say we'll create unique index. So we'll create a unique index. Let's call this unique index customer order. So we'll create unique index customer order on the orders table, and we want to do this on 2 columns like the customer number and the order number. So this will now create a unique index, and we said that when we have 2 columns like this for the index, it creates a unique index where the combination of both still results in unique. And so we can run this to create the unique index where we have just unique values for the index. And this will now optimize search when you want to search the table or you want to create a query that returns the customer number and the order number combination. So whenever you have your system that has a search criteria, and that is a frequently searched criteria, you want to have an index with it. And you want to be careful and don't create index for the sake of having indexes, because all you want to do here is to optimize performance and not have too many index that it doesn't make sense on performance anymore. Right? So the key thing is you create an index for a frequently looked up criteria. So we can show all the index we have on the orders table by doing this. Let me comment this out. We'll say show keys from orders in the classic mode. So now you can see all of the index that we have created here, and we know all of the columns that we have indexed. If you want to delete an index, let's say we want to delete the index ship status here. So we'll do drop. So we'll drop index and then the name of the index, ship index ship status on orders, like that. And then this is going to delete that index. So there are little more details about indexes that I want you to research and read. Like when you create an index, you can add an algorithm, and or you can also add the lock option when you do the creation. And all of these are optional values that you add when you run your create index statement, but the default values are just okay for us for this course. You want to go deeper and read the SQL documentation on these statements and go further to look at the optional statements and the values that those options can take. So after we created the index that we use a prefix, when we want to run that query, we use things like, let's say, select all from others where the status. Now we can use the like operator now, because let's say we want to select all where the status is cancelled. Now this is going to go faster because we already use prefix and we use 2 characters. So you will now say where it starts with CA or something. Now that we have an index that uses the prefix for a string column, it makes it even faster, and you see this effect better when you are using a large table. Now you can even make our queries faster, like in the case of when we want to have a functional index, an index that runs aggregate function. We can do that by saying, for instance, let's say explain, let's do select count. We want to select the total number of all the orders where the month. So we want to run an aggregate function, and we say month, the column name is ship date. So where month ship date is equal to, now we're running an aggregate here, and this will slow down the speed of execution. If this is a frequently accessed query or a frequently lookup query, like when we're doing data analysis, you might want to create an index for this type of query that makes it even faster. And how do we do things like this? We create an index and want to create the index on order and put the aggregate function on the index that we created. Let me take this out and I'll say, I'll use the statement, I want to create index, and the index I want to create, I'll call it index month on others, and I want to do this on the shipped date column like this, but I want to run an aggregate function for month, the months taken from the ship date. So we have this index created, and now when I use this, explain select count where ship date is 02, this will now go faster, and it uses the key index month to make this optimized. If I do just run the select query, we will see that it gives you 28 count. So I'll remove the count and I'll just run this, and then we have everything where the month is 02. But you see that we run this query just looking at the month regardless of the year. So we want to see everything in February every year for whatever kind of data analysis that we want to do. So when we try to run a select query like this, we can decide what index to use. We'll have different index, we have unique ones. You create several index and you want to force the query to use a particular index. You can write your select from table name, and then you now put use index, and then you put the index you want it to use here, and then it uses that index. If it doesn't use an index and you want to force the index, you use force index and you put the name of the index you want it to use there. Okay, so you can add this option in your query when you want to force it to use an index, or you want to select an index to be used, you use index. So this is where we end this lesson. In the next lesson, we're going to look at how to create views in SQL.